Now let's go to the second question, which is one of the most asked question. And to be honest with you, if somebody don't ask me this question, I will be really surprised. Like, this is the must go to question for each and every interview. So the question is, provide a detailed explanation of the sequential steps involved in booting up a Linux system. So basically, what the interviewer he wants to ask us is the boot process. Okay, or I will say Linux boot process. Okay, and I have this diagram where I have explained like how this boot process works. But again, rather than me trying to say like explain like what this diagram is doing, we will try to break it and try to explain this as a step by step. Why do you think? I mean, we can start with this one. Like, in your real life or in your day-to-day life, how can you correlate a boot process with something which is, I mean, you are using every day? Is there anything which you can correlate? I mean, forget about the server part, but there's something which is you are using every day through which you can correlate the boot process. Yeah, waking up is one thing, but I'm just talking in terms of our devices. Exactly. Mobile. Yeah. So when you turn on your mobile, you will see that the bunch of steps which is happening, and even your mobile, for example, the Android devices, they are using the Linux operating system in the backend, right? So when you turn on your mobile, the bunch of steps happen, and after that, it will uh, show you that screen. Okay. Similarly, is with your laptop, right? You when you turn on that power on button, it perform a series of steps, and after that you will see the login screen. So all the steps it perform in the backend, that is called a boot process. Okay. Now, why we want to discuss this boot process? Why do you think that is really critical in terms of server? This boot process, why this boot process is critical to the server? Yes, exactly. So think of it again, try to correlate it with your mobile. Okay. So if your mobile is not working, you might be impacted. But let's say this server, which is hosting your important critical application or the website of your company. And if this server is not booting up, that will impact the availability of your service, right? So that's why this boot process is important. Your server must need to be up and running, right? But just to give you an idea, like in the early days, and when I say the early days, I will say in the 2000, when the cloud is not a popular thing, or like at that time, we have a limited amount of servers, right? Nowadays, you have elasticity. At any point of time, you can boot any server. So at that time, the availability was really important. Okay, you must need to have your server up and running at all the time. And in case if you need to replace your server, that is like a time-consuming process. So somehow this is a kind of a legacy stuff which is coming uh, uh, from the earlier time, but somehow this is one go-to question. Okay, and I can tell you based on my experience in my past company in Red Hat, we always ask this question to the person because we want to understand how much you understand about the basic stuff. Okay, so exactly the availability. What will be the first step? So I turn on the mobile, means I turn on that switch either in my mobile or on my laptop. What do you think what will be the first component which it need to check? If that component failed, your server should not be boot up. So what do you think what should be the first step? It's already been mentioned above, but I just want to hear it from you guys. BIOS is correct, but there should be one more thing. Exactly. Mohit, you are correct. So required hardware. Exactly, guys. You're on the point. So if any of the hardware component is failing, there is no point to boot the system to the later stage, right? So hardware should be up and running. All your components should be functioning. And that's why what Himanshu had mentioned, the first step is called power on self-test. It is called post. Right? This post step runs, and this check if all the hardware component which is connected to your system should be up and running, right? And if it's not, it is going to throw an error. Let's say your RAM is not functioning properly, your CPU is not functioning properly, then there's no way your server is able to boot it up, right? So this is the first step which happens, which is called power on self-test. Okay. Now let's go to the next step. But before we go to the next step, let's say up to this far, we have turned on our system. Uh, System has performed this power on self-test and it checked all the hardware devices and everything is functioning properly. Now my question to you guys, where do you think this power on self-test, or called post, resides? In which location this things reside, this power on self-test? So basically it resides inside something called BIOS or UEFI. It is like something which is embedded inside it. Okay. And that component is called firmware. So firmware is basically a thin layer which enables a communication between this software and your hardware system. Oh, sorry, between the hardware and the software. So for example, in this case, our operating system. Okay. That's the work of the firmware. Now I have used two terms here. One is called BIOS and second one is called UEFI. Do anyone know what is the difference between this BIOS and UEFI? I know we are going much on the hardware part, but unfortunately, all these questions appear during the interview. So I must need to ask you guys all these questions. So anyone know BIOS? We all know it's basic input output, right? What exactly the UEFI stand for? Or my next question is why we are using UEFI more nowadays. So basically, BIOS is developed somewhere in 1980s, right? And by 1980s to like 2023, we have seen a lot of changes in the hardware. So I can give you the basic example. In 2002, I got my first desktop. Okay. And that desktop has like 128 MB of RAM and 256 GB of hard disk. But if you look at nowadays, we have like a terabytes of RAM or terabyte of hard disk, which is quite common. Okay. So BIOS was developed when we don't have all these enhanced hardware. And that's why it comes out with the concept of called UEFI. It was earlier called EFI, Extensible Firmware Interface. And now they have added this Unified Extensible. So basically, one of the key difference between this UEFI and BIOS is that BIOS has a limitation that it can only read a hard disk up to 2.2 terabyte. Okay. Now, again, the question back to you guys, why do you think this limitation exists, this 2.2 terabyte? Chaitanya is correct. It has, I mean, it's something to do with the legacy stuff, but at the same time, it can only address the 32-bit sector addressing. And so that means it can only read the 32-bit sector, up to 32-bit sector in your disk. While this UEFI, it can address up to 64-bit. Okay. So if you go to 2 raised to power 32, that will come to 2.2 TB of hard disk. So in case if you need a hard disk more than 2.2 terabyte, which is quite common nowadays, you must need to go with a UEFI. Okay. So that is one of the major use of a UEFI based system. I can show you the diagram, BIOS versus UEFI. So if you look at the BIOS, you will see this kind of an interface. But if you look at the UEFI system, yes, this one, you will see this amazing UI also. BIOS is mainly the N-curses based one, and UEFI is most of a graphical one. And it also to do with some kind of a addressing, like it can only read up to 8-bit. And that's why you see all this UI, this kind of interface, whereas the N-curses can read up to 16 or 32 bits. Sorry, the UEFI. So that's why you see this kind of a nice UI for even at the hardware level. Okay. So I know we have done this. So far in our journey, where we are. So we have turned on the machine, right? We have performed the power on self-test. We have done with this BIOS and UEFI. What do you guys think? What will be the next step? Yes, exactly. It now need to find out the boot device. Okay. And because ultimately at the end of the day, it need to boot up your system. And in order to boot up the system, it need to find out that boot device. And that boot device is present in the first sector or first 512 bytes, which is called MBR or called master boot record. Okay. Copy this. And actually it is present on the 446 byte. I know in one of the interview they have even asked me, like, try to separate this between the 512 byte and where exactly the partition lies. So in the first 446 byte, it loads something called GRUB1 stage bootloader. And then in the next 1 MB is a GRUB2. And the function of this GRUB1 stage bootloader is just to load this GRUB boot2. That's it. Okay. So now you have your bootloader. Anyone wants to speak about what exactly is this bootloader? What is the role of that? Yeah. So the function of your bootloader, which is called GRUB or a Grand Unified Bootloader, is to load the operating system, right? So basically, I can even show you that GRUB screen. Basically, this is how it looked like. So this loads and it will give you an option. Okay, you need to select, for example, the Ubuntu based operating system. Here it is only showing the one. Let me show. Yeah, even here. But you will see that it will able to boot from the multiple operating system. So GRUB basically provide you a function through which you can boot multiple operating system, and it can even support Windows also. So you have called GRUB, which is now the newest version is called GRUB2, and you can select between Windows or even any version of, for example, you can have Ubuntu, CentOS, Red Hat, all those things. And even you can set up a password at the GRUB level. Okay. So let's say you have selected this Ubuntu based operating system to boot up. And once you select it, it loads the kernel, right? Now, at this stage of time, do you think we have already spoke about it, this device driver or a module? Do you think we have all the modules present at the system to boot up the kernel or to load the root file system? Okay, let me repeat the question. So basically, you have selected the GRUB from the GRUB menu. You have selected that okay, you need to boot the Ubuntu based operating system. You have selected this particular kernel, and at that point of time, do you think that you have a sufficient drivers or a modules present to boot boot up the root file system, or to load the root file system, or to mount the root file system. So we have the minimal. And do you guys know who provide that minimal drivers that is needed by the kernel? Who is responsible for providing that minimal drivers? Exactly, initramfs. So let me show you if I already have, yes. So you will see that this is VM Linus, which is the main kernel, and you have something called initramfs. So this is the one which is loaded along with the kernel during the initial stage, and it will provide the necessary driver for your kernel so that it will boot the minimal amount of a root file system. And idea behind it, because they want, I mean, whoever who developed this whole system, they want to keep your kernel to be as minimal as possible. They don't want to load all the drivers at one go. So they want to keep it as minimal as possible. And that's why all the necessary driver which is needed to mount the necessary devices, that is present on the initramfs. All the rest of the thing, they will be loaded at the later stage. Okay. So far we have selected the kernel, we have mounted the root file system. What do you guys think? What will be the next step? So the first process which is going to boot is called systemd. If you are coming from the, yeah, I mean, Chaitanya, I don't want to go into that much depth that it is going to boot it's something called a switch root process. Yeah, Chaitanya is absolutely correct. It's a switch root process, which is then going to mount the root file system in the read-write mode. But okay, so we can go in the interest of time. The first process which is going to boot is called systemd. And if you coming from the earlier version of Linux, it was called init, but it is now replaced by the systemd. I have wrote the entire blog how systemd works. We can talk about it later, but the first process which is run now is called systemd, and this will become a parent of all the process which is going to be boot up in the system now. Okay. Now, init systemd is booted. Once again, I have the same question. What do you think? What do you guys think? What will be the next step?
User space.
Yes, user space, but the more appropriate term for that is called targets. Or if you understand, I mean, if you're coming from the earlier Unix operating system, yeah, Chaitanya, it's called run levels. So basically in systemd language is called target. Target is not really equivalent to the run level, but in the layman term or in the simple terms, we can say target. So if you understand the run level, let's say if my system is on run level 3, which is called a multi-user mode in case of systemd. So it is going to go to that particular run level or this multi-user mode, and it will boot up all the services which is required for that particular run level. So for example, in the run level 3, you need all the networking services, right? All your Apache server, let's say you are running an NFS server. So all those services, it is going to boot up. And finally, we will see the login screen. So yes, I mean, finally, we are able to boot up the system, right? So congratulations. So you are able to, I mean, clear one of the most difficult question, because if you see the entire boot process, they can ask you a lot of question in between. Okay, so let me summarize that. So first step is the power on, which is called power on self-test or a post, where at the firmware level, or it's a chip which is embedded inside your BIOS or UEFI system, it will check, okay, all the hardware device, they are functioning properly or not. Okay, and then we have saw the difference between the BIOS and UEFI. UEFI is basically for the newest hardware. Any hardware which need a disk more than 2.2 terabyte, it will go with the UEFI, and it's called Unified Extensible Firmware Interface. Then once it has been done, it will try to locate the first hard disk on your system, which is called in the MBR partition, a master boot record, or in a case of UEFI is called GPT partition, which is called the GUID partition table. We haven't spoke much about it, but let's keep it short. Once it located the first device, it will go to the GRUB, okay? And at the GRUB, you can select the kernel, which kernel you need to boot. Once that has been done, you select the kernel, it boot the kernel, then it goes to that initramfs stage, where it will have all the minimal amount of driver which is present in your system, and to load the /root partition in the read-only stage. Then the switch root happen, which will transition it to the read-write mode. The first process which is going to boot is called systemd, or in the earlier stage it was called initd. Then it will go to the targets or run level. Depending upon the targets or run level, it is going to boot the targets. And it goes to the user space, it boots all the application, and it will go to the logins.